All right, thank you for inviting me to present this paper. It's particularly fun because I can help educate Jonathan Burke, so that'll be fun. I'm teasing. I kind of, Jonathan's concerns were, I had sort of an episode on the plane, kind of like Jonathan's outburst when I was trying to understand the paper a bit better, but I think I understand it better now. And I'll try to use a little simple example to try to help us all understand the message of the paper. Okay, so the first part of the paper starts out with these sort of interesting empirical results, which are, it's well established there are risk premia out there, and the interesting fact is that a lot of this risk premia, particularly if we think about aggregate equity markets, comes around these announcement days, which are very short periods. I mean, just, this is the table that was shown during the presentation, but a big chunk, at least in the broader sample, so we have a equity premium of 6.19%, right? If we focus on announcement periods, these are short periods, like a day, or during the presentation we saw during very short windows of 3.36%. Okay, and so the basic idea, I think, of the paper is to say, well, okay, so there's a resolution of uncertainty clearly around these announcement dates. It seems implausible to think that consumption contemporaneously is moving dramatically over a day in response to these things to generate a standard risk premia as we would do with time additive expected utility. So that's the basic idea. So one of the theme I'm going to come back to in terms of thinking about the general properties and theory here, there's two components to this. There's not the theorems need to state better something about the shock structures. And it's really this presumption that we're talking about shocks where contemporaneous consumption doesn't move, which is okay, I get it, but that's absolutely important to think about this important term, importance of the second term. So I'll just use a little example to kind of work through it. And I'm not going to talk about the general theorems that are in the paper about stochastic dominance and so on. I'm just going to use a standard sort of recursive setup that I'm comfortable playing with to talk through the intuition and then raise a few issues. So I'm going to write recursive utility this way. This is the CES kind of aggregator between current consumption and some future value, right? So this is Epstein-Zinn, Krebs-Porteous sort of setup, kind of workhorse model that people use. Bansal and Yaron's papers have this kind of structure in it. Okay, and there's this term. Let's see, how do I, oh yeah, this term here. So we have this distortion coming with the way investors think about this future and risk aversion. You know, we have to be careful with terminology, but let me have sort of loose terminology here. Risk aversion is embedded in this parameter gamma, and it's about variation about the future. And then there's intertemporal elasticity, which is driven by this parameter rho. And now, in a world of randomness, that distinction is a little difficult to think about, but just roughly we think that way. And what's expected utility in this case, time additive expected utility, rho and gamma are the same. And we get this form, ignore this term here, but present discount, what's utility today, present discounted value of future consumption with some power that's now reflects risk aversion, okay? All right, in these models, what's the stochastic discount factor? And it's driven by sort of a standard term we would think about with a time additive expected utility and a discount factor beta, and then this extra term here. So let's take an example. When rho is equal to 1, okay, so that's log sort of intertemporal preferences. You get a second term here in the discount factor. So that would be the standard discount factor, right? The inverse of consumption growth. And then you get a second term here reflecting this continuation value. Okay, and risk aversion, this gamma parameter enters there. And in this case, we call that thing MT plus 1. In this case, that thing actually, its expectation is 1. So we think about some probability distortion induced by preferences. Distortion is kind of a bad word. The investors are kind of rational. It's not, but there's a change relative to the actual conditional probability distribution This adds to 1. They're all positive, so that's a probability distortion. Now, one comment I would make in the paper, about the paper, it's not a general result, certainly in this class of preferences, that this is a probability distortion relative to expected utility. So there's a little discussion there, like, whoa, wait. That's not a general result, okay? It depends on different parameters. So it sort of affects the way we interpret this thing. But roughly, certainly for close to log case, we have a distortion here coming from this continuation value, in this context, the importance of resolution of uncertainty and so on, to think about this second term. Okay, so that V thing, just to help you think about it, in a sort of parametric versions of this, say there's log linear dynamics for all the shocks, again, log preferences across time. You can show that that V thing, this continuation, this future, is about the present discount value of future consumption. So what shocks, when investors are thinking about the importance of shocks and risk premium, they're not worried just about the effect on current consumption, okay, or contemporaneous consumption growth. They're worried about the effect far in the future. So this probability distortion relative to time added expected utility is that, right? So it's something about these shocks, sort of announcement shocks, affecting the future of consumption, not right now. So it seems untenable to think it's about right now, right? And again, the paper, the tenor of the paper is more about, well, let's write down sort of more general discussion of the properties as V, but I want to take kind of this V thing in this kind of rough context to think about this way. And this is where these long-run risk models come in. They say, well, look, we're thinking about risk premia, say, and announcement effects. Short term, there seems like there's nothing. It's about resolution of things way in the future that matter to these investors. And so it might be evidence of the importance of these announcement effects on the long-run future of the economy, which seems plausible, right? Then that's the importance of this term. Okay. Now, let's see if we can, so, there's kind of a mess up here, but in the paper, one thing I would suggest in the paper, I don't get why you have to have 0, minus, and 0 plus, and then 1. I like how about 0, 1, 2, okay? And it's just a pain. It's confusing. But I think it would make it much more clear about what they have in mind in terms of the shock structure. Okay, so I'm going to write, what have I got here? PT, T plus 1, T plus 2, 0, 1, 2, all right? And so we have, how do we do two-period pricing? There's some payoff y t plus 1. How do we price it today? We discount it over 2 periods. So there's the product of margin rate of substitution over 2 periods. I didn't know I wasn't allowed to wander. That's bad. Okay. Sorry? That's the line? This should be there should be some electrical fence or something there. One of those dog collars around my, yeah, so. And then these product of these probability distortions would be in here, okay? And so prices at time t plus 1 would be 1 period discounting. And so, standard result, prices at time t are discounted value of prices at time t plus 1. Okay, fine. So what they're assuming, and thinking about this implication about risk premia, is that essentially Ct plus 1 is known today. Or the other way to think about it is it's just not much related to the shocks, the resolution in information in the Fs, right? Okay, so what's a 1 period risk-free, one period risk-free claim price? It's just the present discounted value of 1 unit. So you'd have this probability distortion, the expectation of mt plus 1. That would be the risk-free value. If mt plus 1 is unrelated to pt plus 1, so that's this distortion or this importance of resolution of uncertainty, these non-Knightian preferences or whatever. If that thing is unrelated to the price, then what we're going to get is the price today. This term comes out because it's constant, it's known, and we could, you can generalize that to have some variation there. Either the expectation, well, there should be a conditional there. Right? Conditional expectation is m. In this example where rho and gamma are rho is 1, this would be 1. But in general, this is the risk-free value, this component. So the price today is a present discounted value of the price tomorrow at the risk-free rate. And again, what's really critical here is the assumption about the impact of the shocks on various things, in particular, the impact of the shocks on consumption. All right, that's the assumption. It's not just about preferences per se. All right, so you could think about, well, how do you get now risk premia in this model conditioned on this part, right? Conditional on CT plus 1 known. How do you get risk premia? The only source now comes from variation in the M and how it's related to prices. And that's about, the theory in the paper is about how that M moves with prices, the notions of second order stochastic dominance and so on, how that thing varies to generate risk premia, right? So that's what the theory is about. So again, I'm probably saying it too many times. I think the paper needs to be much more clear about it's a joint discussion of preferences and it's some assumption about the shocks we're looking at, all right? And you can't identify the preference parameters without that latter assumption about shocks, okay? It's a joint set of assumptions. Okay, so interpretation, if you think of it over the very short run, consumption's unrelated to the shocks from macro announcements. Look, I get it. It's not like I read the FOMC announcements and change. Well, maybe I might have more wine or something that day, But in terms of big plans, big parts of my consumption, things don't change. And if things are, again, CRA, time separable utility, this M thing is constant or unrelated to the shocks, you get no risk premia. So the observed risk premia, and very large risk premia around these announcements, is evidence of importance of this M under this assumption about the shock structure. Okay, so M could come from non-expected utility, risk central control models, continuation values, long-run risk models, Knightian uncertainty ideas. There's various ways in which to map into this recursive setup to get this to go. One thing I think would be important for the paper to acknowledge or discuss is really there's a bigger literature out there that's thinking about sort of this temporal nature of risk premia, right? So Van Binsbergen, Brandt, and Koijin, I left as co-author, Koijin out there, they have this interesting paper about dividend strips and the temporal pattern of risk premia, short-term higher risk premia versus long-term. Letow and Wachter have a similar discussion about risk premia over time, what it says about preferences. Lars Hansen has a more recent paper sort of summarizing a lot of this stuff, looking at risk pricing over different investment horizons that helps us think about, what are the structure of shocks that investors are thinking about, how do you think about preferences and so on. It'd be nice to sort of acknowledge that I think this paper sort of sits in that broader literature, all right? Now, one thing though, I would say this whole distinction, say, okay, we need non-expected utilities. Like, okay, now, is this a philosophical debate or what are we talking about here? So any kind of non-separability over time could generate these effects, all right? So, for example, my favorite one would be, stochastic discount factors, they're about ratios of marginal utilities. And C just says marginal utility consumption. If things are durable, say, okay, you have a shock today, you're going to purchase a car in the future, okay? Because there's some relaxation of interest rates. That affects your marginal utility of current consumption, okay? So, because you care about your future self through the linkages, just the physical nature of the good and nothing to do with quote unquote preferences, right? So, we should be a little careful. Again, there's another part of these assumptions is the nature of the consumption they're talking about. Yeah, it's this infinitely, it's disposable instantaneously in the continuous time model versus I think reality is people are making plans about big consumption decisions that have very persistent effects on their utility, right? More generally, think about the classic problem, right? When we're first writing down, or Merton or whoever is writing down, control problems in continuous time or here in discrete time, you are writing down a portfolio control problem with some utility over terminal wealth. Expected utility. It just happened to be what you cared about was yourself in the future, right? And so in that world, indeed, you would get time varying or risk premia that would be a function of the state of the world as uncertainty evolves, and it would be expected utility, right? So the impacts of these shocks would have an effect. There's a bunch of symbols up there. It doesn't really matter. You're about to tell me 0. Good, I have 1 page. So this alternative model, how do we think about this alternative model? In this alternative model, there's some future self you're worried about, yeah? And you're managing your portfolio to maximize your utility when you get there, right? Under expected utility. And in that model, expected utility, we'd get this risk premium, potentially, depending on the nature of the shocks, how those shocks to information affect stock returns and so on, these endogenous stock returns. So how do we think about these periods? So another way to think about this is, do we really want to take seriously this notion of control over consumption at such a high frequency? And I personally think, well, I'll say no, okay? I think, what you really, and I understand it's interesting to think about sort of this idea of this is telling us something about preferences, and I think that is important. However, the first order thing, if I was thinking about this, is really what's going on is we're seeing, say, the impact of delegated portfolio management or inattention or periodic consumption adjustment, and investors are trying to, these announcement effects change the nature of the investment opportunities available to them, and they're responding to that, and that's what's generating risk premia. And you could get that even in an expected utility model with some sort of periodic adjustment due to cost or something else. Inattention, I guess, is not expected utility, right? Some behavioral story, but something like that. So in addition to thinking about this temporal nature of these shocks helping us with preferences, they might also be telling us about these other kind of frictions that are going on in the world in this periodic adjustment of consumption.